Hi everyone, and welcome to the third of 4 videos going through some past exam questions on bonding and structure. So the first question is asking us a little bit about the periodic table. What is meant by the atomic number? The atomic number is the number of protons. Let's say number of protons in an atom. Okay, that's a nice easy 1 mark question. Then it wants us to give the full electron configuration for titanium. Okay, so if we find titanium here on our periodic table, titanium's atomic number is 22, so it's going to have 22 protons and therefore 22 electrons. Okay, so if we've got 22 electrons, how do we build up the electron configuration? So it's 1s2, 2s2, 2p6, 3s2, 2, 4, 10, 12, so another 10 electrons, 3p6, 4s2, 2, 4, 10, 12, 18, 20, okay, and then it must be 3d2. And remember 4s comes before the 3d. Technically speaking, you should write the 3d first, but they'll let you do this in the exam, and it's probably easier to remind yourself that the 4s comes first if you do it this way. Right, and then it wants to identify the 7th element in the 4th period. Okay, right, so let's get our periodic table again. So period 1 is just hydrogen and helium. Period 2, period 3, period 4. So if we have a look at this bit, so 1, 2, 3, 4. The 7th element, 1, 2, 3, 4, 5, 6, 7. So it's manganese. And what block is it in? So manganese is here in the middle of the periodic table. So this is the D block, isn't it? We've got the S block over here in groups 1 and 2. And then the other side here, you've got the P block. And the D block is in the middle, so it's in the D block. Okay. Right, it then says lithium has a giant metallic structure and a very high boiling point. Describe with the aid of a diagram the structure and bonding in lithium and explain why it has a high boiling point. Now, we've seen a very similar question to this in a previous video. So lithium is a giant metallic structure. They've told you that, which is a bit nice. I probably would have expected them to make you work that out. Okay, but so therefore it's going to be some lithium ions. It's always better if you actually write the charges rather than just like labeling them as positive ions. It shows that you know what the charge of lithium actually is. Okay, so it's going to look something like this with a bunch of positive lithium ions. And then it's going to have delocalized electrons dotted around the place. So let's label these up. These are positive metal ions. And these are delocalized electrons. It's always a good idea to label the diagram. So the structure and bonding in lithium. Okay, so lithium has a giant metallic lattice structure. And it has a high boiling point. Because strong electrostatic attraction between the Li+ ions and delocalized electrons requires a lot of energy to overcome. And we said that before in a previous video, didn't we, that it's usually a good idea to say that if you've got a strong bond, it takes a lot of energy to overcome. That's usually worth an extra mark. Okay. Then the next question is again one that's very similar to one we've seen before. Okay, they seem to like these two questions in sequence where you get one question about drawing the metallic lattice, and then the next question is explain the differences in the melting points of two different metallic lattices. Okay. Although actually these are from two separate questions, but these two questions seem to come up a fair bit. So explain the difference in the melting points. Okay, so the thing that's holding them together is the attraction between the positive ions and the delocalized electrons. If you've got an element with a higher melting point, it must be because that attraction is stronger. And so the reason for that is going to be down to the ions. So we can say that the magnesium ion has a higher charge than the sodium ion. And if we write them like this, then we're showing that we know what the charges are. Magnesium has more. Actually, let's put the actual numbers in. Rather than saying more, we can say magnesium has 2 delocalized electrons per atom, whereas sodium only has 1. So this means that there's a much stronger electrostatic attraction. So this means the electrostatic attraction between positive ions and delocalized electrons is stronger in magnesium than sodium and requires more energy to overcome. Okay, and then finally this question here says, state whether the following substances conduct electricity when solid or molten, and explain your answers in terms of the particles involved. Okay, so let's just work through these. So aluminium is a metal. Metals always conduct electricity. So aluminium conducts electricity when solid and when molten, because it has delocalized electrons. It's delocalized electrons that move through the structure. Okay, what about aluminium fluoride? Aluminium fluoride, again, I'm going to bullet point this just to make it clearer, just to help myself really. Aluminium fluoride is a giant ionic lattice. We've got a metal and a non-metal. So if it's a giant lattice, remember it's not going to conduct electricity when it's solid, but it will when it's molten. So aluminium fluoride does not conduct electricity when solid. Because the ions cannot move. It does conduct electricity when molten, because the ions are free to move. Okay, and then finally, the last one we've got here is the boron tribromide. Okay, so this boron and bromine is going to be a covalent compound. So boron tribromide does not conduct electricity when solid or when molten, as it has no delocalized electrons or mobile ions. It doesn't have either of the things that allow the other substances to conduct. Okay.